Hi everyone, it's Miss Barker. We're going to do a simple little example using the connection between the linear and angular quantities with the helicopter blade. So we have a helicopter blade that has an angular speed of 6.5 revolutions per second and an angular acceleration of 1.3 revolutions per second squared. For point 1 on the blade, which is here, find the magnitude of the tangential speed and the tangential acceleration. So first, of course, we have to identify our givens. And we're given the angular speed, that's omega, as 6.5 revolutions per second. Unfortunately, that's not the units that we want angular speed in, so we have to convert it. From revolutions per second to radians per second. And 1 revolution is equal to 2 pi radians. So if we do that out, we're going to get a value of 40.8 radians per second for omega. Next, we are also given the angular acceleration, which is alpha. And we're given that as 1.3 revolutions per second. Revolutions per second squared. So again, we do have to convert that. Into radians per second squared this time. And that results in an angular acceleration of 8.17 radians per second squared. Now we're able to look at how are these quantities connected to the linear values. And it's a simple relationship where speed equals r times omega. And we were also given the radius. If we look at the diagram, the radius is 3 meters. So we're just going to simply plug in using our converted value of 40.8 radians per second, giving us an answer of 122.4 meters per second. The second thing we were asked for was the tangential acceleration. The tangential acceleration is linked to the angular acceleration. And so we're going to use r times alpha, and we have r, and we have alpha. We're going to use the 8.17 for alpha. And that will yield a tangential acceleration of 24.5 meters per second squared. So converting between the linear and angular quantities is pretty simple. You just have to know the equations that relate the quantities, and you have to be able to identify the given quantities from the problem.